Hi, welcome to my video on the inverse trig function on arc cosine, which is the inverse of the cos graph or cosine graph. And to start it off, we need to know what the unit circle is with a radius of 1. And at 0 degree rotation, x is 1, y is 0. And at 90, at 0 degrees, x is 1, y is 0. At 90 degrees, x is 0, y is 1. At 180 degrees, x is negative 1, y is 0. 270, x is 0, y is negative 1. And 360, back to 0, 1, 0. So y equals cos theta, and cos theta is associated with the x. So at 0 degrees, the x is 1. At 90 degrees, x is 0. At 180 degrees, the x is negative 1. At 90, x is 0. At 180, x is negative 1. Just a little mistake that I shouldn't be there. And at 270, x is 0. And back to 360, x is 1. And we can also go this way for the cos graph. And the cos graph, if you're at negative 90, x is 0. If you're at a negative 180, x is negative 1. And if you're at a negative 270, which is here, x is 0. And if you're at a negative 360, which is all the way around, x is 1. So the cos graph is doing this. And it comes down from 1 to 0 to negative 1, back up to 0, back up to 1, and this continues on. So that's the cosine graph. Now, we need to look at the inverse, and the inverse has to be a one-to-one function, so it has to pass the horizontal line test. So if I draw a horizontal line through this function, it'll pass through the function at many points. So its inverse is not a function. So we have to restrict the domain. And again, this is discussed in the inverse function, which is a unit that I done in pre-calculus on the inverse function, on the parabola, etc., etc. Now, how do we restrict it? Well, we restrict it from here at 0, at 1 to 180, which is restricted from here to here. So this is the restriction. So you could restrict it here, you could restrict it here, but the books, the calculators, all go from x is 0 to x is 180. And this is 90, and this is a 1, and this is the negative 1. So that's the restriction. So your domain is the x, or the theta. So the domain is 0 is less than or equal to theta is less than or equal to 180. So your domain values for this restriction is from 0 to 180 degrees. And your range is from negative 1 to a 1. So negative 1 less than or equal to y less than or equal to 1. So this point right here, x is 0 degrees, y is 1. And this point here, x is 180 degrees, and y is negative 1. So when you do an inverse, you do reflection in the line y equals x. So this is the line y equals x. So we do a reflection in that line. And so right here, let's look at this ordered pair. X is 90 degrees, or theta is 90 degrees, and y is 0. So if you rotate these ordered pairs by reflecting in the line y equals x, or okay, y equals x, or is this line, have a y equals theta, where the values are equal to each other. So we got 45, etc., 45 degree. Now, let's look at the inverse. So let's take this point. This point is reflected in this line. So 0, 1 becomes 1, 0. Becomes 1, 0. So this is 1 and this is 0. This point here is 90 degrees, 0 becomes 0, 90. So this is 0, giving you 90 degrees. And this point here is 180, negative 1 becomes negative 1, 180. So negative 1 and 180 is right here. 180 degrees. Again, this is the degree. So notice you've got a negative 1, 180. Right here is 180, negative 1, the reversed. And so this is, let me see if I can draw it. There it is. That's the inverse. So this is the graph of this one is theta equals arc cos of y, or theta is cos to the negative 1 on the y. And again, I'm using theta and y because this is y and theta. So in this graph right here, you plug in the values for theta, which is in degrees or radians, and you come up with the y. So the reverse would be that when you plug in the value for y from 1 to negative 1, you come up with your degrees or radians. And so also the domain and range are reversed because of the reflection. So your domain becomes your range. So 0 is less than or equal to theta is less than or equal to 180. And your range becomes your domain. So it's negative 1 is less than or equal to y, less than or equal to 1. So the reversed, switched around. All order pairs are switched. And as you would with when you're mapping with x and y, the x becomes the y and the y becomes the x. But here I kept it as y and theta. So the reverse is theta and y. So you plug in your degrees, you come up with your value. Here, reverse, you plug in your value and you come up with degrees. So let's look at that further. So instead of drawing the graph with his inverse there, what I do, and I practice this in learning it, I look at where the restrictions are in relation to y equals cos theta. So the restriction is right here. So this restriction is that when x is 0, y is 1. When x is 0 degrees, y is 1. And when x, or x, I say x now, when theta is 180 degrees, the y is negative 1. So I keep this in mind without looking at its restriction, because I know when I do the inverse on this part of the restricted domain here, then I'm looking at this, because if you take this restriction here, if you take any angle between, say, this is a 90, if you take any angle between 0 and 90, then your number is between 0 and 1. If you take any angle between 90 and 180, then your number is going to be negative. So reverse it. If you had a positive number, then if you had a positive number, and this number is 1, so if your number is positive, it lies between 0 and 1. So that means your angle got to lie between 0 and 90. And if your number is negative, it got to lie between 0 and negative 1. So that means your angle got to be here, which lies between 90 and 180. So I don't need to draw the restriction. I don't need to draw the inverse, sorry. I just got to know where my restrictions are cut off at. So let's do some examples. sine of 30. 30 degrees is a 30, 60, 90 right triangle. So if you take the 30, 60, 90 right triangle, opposite 30 is 1, opposite 60 is root 3, and the hypotenuse is 2. So if I just take this 30-degree rotation, now even though I can say this is the unit, I'm going to use this triangle because this triangle is easier to use. I could have 1/2 here, root 3 over 2 and a 1, but I prefer to use this triangle. So what happens when I have a 30-degree rotation, which is, let's say, right here, I draw a terminal arm. I got a 30-degree rotation. This angle, central angle is 30. Drop it perpendicular to the x-axis. I have a 60. So this triangle here is 1, root 3, 2. So if you've got a 30-degree angle, cos is root 3 over 2, adjacent over hypotenuse. Cos is adjacent over the hypotenuse. So what about if you plot a 330-degree rotation? So you start here and go 330 is all the way around right to here. So if this is 330 and you draw your terminal arm perpendicular to the x-axis, then this is 330. So this is 30 also as the reference angle, because 330 from here right to here is 330 plus 30 is 360. So this is a 60. So this is 1. This is root 3. This is 2. But in this quadrant, the y is negative. So the cos of 330 is still adjacent over hypotenuse, which is root 3 over 2. So, but when we do arc cos, which is the inverse, we have to look at this restriction. So root 3 over 2 is positive. That means the angle is positive. Root 3 over 2 is 0.866, roughly right here. This is the angle we have to look at. So the angle has to be between, if you go over here and go down, the angle has to be between 0 and 90. So the answer for this has to be between 0 and 90, has to be 30 degrees. And if you want a radian, you take your 30 and you multiply by pi over 180, and 30 and 186, so that's 30 degrees or pi over 6. I always get my answer in degrees, and then I convert it to radians. So what about if we're looking at the cos of 120? 120 degree rotation from here is right up to here. So let's say this is a 120 degree rotation, right to here. Terminal arm is drawn out, perpendicular to the x-axis. There it is. So this is a 120 degree rotation. So this angle part of the arc here is 60. So that means the central angle is 60. So the reference angle in the triangle is 60. Because the reference angle is always the angle between the terminal arm and the x-axis. That means this angle here is 30. So this opposite 30 is 1, opposite 60 is root 3, and the hypotenuse is 2. Because this is in the second quadrant, the x is negative, the y is positive, and the hypotenuse is always positive. So the cos is a negative 1/2. Cos is the adjacent over the hypotenuse, so it's negative 1/2. What about if we do the cos of a negative 120? So there's a negative 120 starting at 0, is right around, stops right here. So this is a negative 120 rotation right to here. Draw a terminal arm to the rotation. There's the terminal arm coming out where it stops at 120, negative 120. So that makes perpendicular here. So that's a negative 120. So this angle, there's 60 here. So this angle right here is 60. That means this angle is 30. So we have negative 1, we have a 2, and we have a root 3. But the x is negative and the y is negative. The hypotenuse is positive. So the cos of a negative 120 is the same as the cos of this 60. And cos, again, it's adjacent over hypotenuse, which is a negative 1/2. But when we look at cos to the negative 1, which is the arc cos of a negative 1/2, a negative 1/2 is right here. So we have to look at a negative angle. Oh, sorry. Negative 1/2, we look at the angle here, and that angle that hits here, if a negative I have is here, it hits it right here, that angle is between 90 and 180. I said negative, no, it's between 90 and 180. So between 90 and 180 has to be, between 90 and 180 has to be the 120 degrees. It can't be this one. It has to be, so if it's negative, it got to be between 90 and 180. If it's positive, it got to be between 0 and 90. And 120 multiplied by pi over 180, zeros cancel. 6 into 12 goes 2, 6 into 18 goes 3, so you get a 2 pi over 3 in terms of radians. Again, repeat, I always like to look at the graph where the restrictions are, and then I can tell if I got a positive number, then I got an angle between 0 and 90. If I have a negative number, my answer is between 90 and 180. So what about if we have the arc cos of a negative root 2 over 2? And a negative root 2 over 2 is, cos is root 2 over 2 is a 45 right triangle and is negative. So because this is negative, what we have now is that we add sugar to coffee, and that's add sugar to coffee. Everything is positive here, all. Sine is positive, tan is positive, cos is positive, and the reciprocals is positive. Cos is positive here, so that means that the other two are negative. So sine and tan are negative. Tan is positive here, so cos and sine are negative. Sine is positive here, so cos and tan are negative. And the reciprocals, so whatever the primaries are, the reciprocals are the same. But we got a negative root 2 over 2, and that's for the 45 right triangle. And that's in quadrant, it's a 45 right triangle. So do I need to plot them? I know it's a 45 degree angle. But because it's a negative, then it has to be between 90 and 180. So that means it has to be 135 degrees. So really, between 90 and 180, you got to be in the second quadrant. So you got to go out here, and that's 135 degree rotation. Because it's a 45 degree right triangle, it's 45, 45. So this is a 1, 1, root 2. Cos is positive, sine is negative. So negative 1 over root 2 is the same as root 2 over 2, negative. So the answer is 135 degrees, and 135 multiplied by pi over 180, 45 into that goes 3, 45 into 180 goes 4. So we get 135, or we get 3 pi over 4. So we don't have to get where we have to look at a restriction, because we're doing arc cos to the negative 1. We just got to look at where the restrictions are and go to that quadrant. Now here, cos, arc cos of a half. Again, it's positive. So if it's positive, it's going to be positive right here between 0 and 1. If it's positive, it's going to be between 0 and 90. So that means we're going to be in the first quadrant. Drop a perpendicular. And cos is the adjacent over the hypotenuse. So adjacent is 1. That's hypotenuse 2. This must be a root 3. So because that's the adjacent, that's the hypotenuse is opposite, this must be a 60 degree angle. This is the 30. So the cos of 60 is a half. And that means, because again, looking up here, your angle got to be between 0 and 90, so it has to be in the first quadrant. And 60 degrees, 60 multiplied by pi over 180. 60 and 180 is 3, so that's pi over 3 as a radian. And we also have the arc cos of a negative root 3 over 2. So a negative number is right here, so that means it has to be between 90 and 180. And the cos of what angle? So it's a 30, 60, 90 right triangle. So if we look at the 30, 60, 90 right triangle, here. The cos of what angle is root 3 over 2? And the cos of, if that's the root 3, and that's a 1, and that's a 2, then the cos of 30. So this is a 30-degree angle, but it has to be in between 90 and 180. So if you draw a circle like this, the angle has to be between 90 and 180. So 90 and 180 here, so it has to be a 30. So that's a 1, that's a 2, that's a root 3, and that's negative. So the angle, that's the angle in perpendicular here, right angle. So the cos of this reference angle is negative root 3 over 2, and that means this rotation is 180 minus the 30. So this rotation is 150 degrees. So 150 degrees gives you a reference angle of 30. And 150, you change 150. Let's see, 150 degrees multiplied by pi over 180. Cancel the zeros. 3 into 15 goes 5. 3 into 18 goes 6. So it's 5 pi over 6. Again, it takes time to work it through, but again, the restriction. Where, if it's positive, it got to be between 0 and 90. Positive number is here, so the angle got to be going down here between 0 and 90. And if it's negative, it's got to be between 90 and 180. And the arc cos of negative 1. So where's negative 1 here? So it has to be 180 degrees. And 180 degrees is pi. So that's a little video on looking at the arc cos, the inverse of cos, the graph of the inverse of cos, and picking out the angles. Oh, I forgot, just for a second, just look at my calculator here, turn on the calculator. What about if we did, let's look at a half. Let's see what, if we're right with a half. The arc cos of a half. So let's do the inverse cos, inverse cos of a half. Half is 0.5. Let's see. We have what here? 60. Let's see if we get a 60. Perfect. What about negative root 3 over 2? So the inverse cos of a negative root 3 over 2. And negative root 3 over 2, I got to memorize, is 0.866. And the inverse of that, again, negative 149.99, which is 150. So when you look at when you do arc coses, arc sines, or any inverse on a calculator, it'll only give you a positive number, which is always, move the calculator, the positive answer is always between 0 and 90. But the negative answer is either with cos, the negative angle, the negative number, it will be between 90 and 180. With sine, the negative number will give you an answer between 0 and negative 90. Well, you got to memorize where the restriction is or be able to come up with it. And if you understand what's happening, you can always correct yourself and come up with it correctly. And again, if you like my video, click on the like button, click on the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content that's on my YouTube channel called Math Fully Explained. Just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.